Good morning. This is technically morning because I'm live, but you also might be watching this later because it's our lesson for next week. So we are doing Algebra 2 notes live. Good morning. Yeah, I have people here. Good morning, Maya. And maybe Lauren. Who's my other one? I have two watching, it says. I don't know. Hopefully this helps because you're gonna be asking me questions as we go, is my goal. That way I can answer them, because I'm afraid that I'm doing things that you don't understand, and I don't know that you don't understand. I can't see your faces when I'm doing my notes here. But I'm also keeping in mind that I have to keep it kind of short, because I want the people who are all watching later to not have to do the fast forward kind of thing. Because sometimes I say, hey, pause it here and go on, or try this one. So we're going to figure it out together. Okay, just to check in though. Oh, it's just you, Maya. The other person went away. Just to check in, you should have this one done already. This homework. I'm so nervous right now. It's fine. You should have this done already because we're going to be referencing it today. So if you don't have it done already, maybe see if you can ask me questions, but it might be that you haven't done this, so that's why. So this week, 2 days ago, I dropped this lesson, which is where we made the unit circle, talked about some triangles in it, and made the sine, cosine, and tangent just for this section. That's what we did last week. And the reason we did that last week, or this week, Maya, why are you concerned? I'm confused. Oh no. I gotta catch up here. Okay, I'll catch up. It's not immediate, my questions and your answers, so. Maya, I'm so sorry. Because my lessons are due Mondays, this is my lesson for next week. So I'm just doing it early. So it's all good. This was our Monday lesson. It's going to be off by a week, and then this week's just kind of short. But it's okay. Just let's do this together. Apparently just you and I, but we'll figure it out. We'll see if anybody else joins in. I would say pause it and do it and come back, but I don't know how this works. I don't think you can pause a YouTube live stream. It's all good. Yeah, so this is next week's lesson, but today. Because I had some cool, pictures going on last time. It's fine. We'll figure it out. It's all good. Maya, let's learn together. And if you ask me questions, it's fine. But I'm going to draw on this one. So when you get this done, just come back and do it. Or I'll just talk to myself and you can go do it. It's all good. Okay, so I'm on 57. And this is 9-3. B, technically. Because 9-3 was the unit circle from last week. Yeah, it'll be confusing, but it's fine. And this is trig in the unit circle, which, if I had a band, it would be trig in the unit circles. It's fine. Trig in the unit circles. Open widget. Luckily last week, or this week, Monday, the lesson I dropped was just to make that paper, because there wasn't any homework to go with it, because all the homework is from today, which is next week's lesson. Nobody's confused. It's fine. All right. So on the unit circle, remember how I talked about, no, you don't know. So I talked about how, wait, I might still have the animation up. We're taking a circle and a normal graph, and we're going to smush them together. Look how good that is. Okay. So I'm going to talk about translating between the unit circle trig stuff and a coordinate plane, normal graph. Can I make this brighter? Nope. That's fine. So we're putting them together. So on, so trig plus a coordinate plane. Ooh. I think it's this. Somebody's gonna at me. Yes! Where? Why did you use all my tape to make a tape ball? That's my #1 hit song for trig in the unit circle. So in trig in the unit plane and the coordinate plane, x squared plus y squared equals r squared. Because of the distance formula. So on a circle, my x direction's this way, my y direction's this way, and the radius would be what connects those two into a triangle. So this is Pythagorean Theorem again. It keeps coming back. Also, sine of an angle is y over the radius, and cosine of an angle is x over the radius. Great. So what happens is, let's walk through a circle on a graph really quick. Do I have space for this? I totally have space for this. So on a graph, this is like a graph, like a normal graph. And I have a circle. If I have any point on this, I have an x direction and a y direction and then a radius. And that works for any angle around the real graph, for any of them. Now let's think about this for just a second. Over here, I can find sine, cosine, and tangent. Over here, I have a positive x. Good morning, Lauren. Lauren, I need to clarify real quick, because I confused Maya. These are the notes that I posted Monday. I've already done these notes, okay? I'm going to be referencing them, so if you have them, awesome. If you don't, it's okay. I'm currently taking the notes that I'm going to drop on Monday next week. So I'm doing it like a half a week ahead, because this is when I normally record them anyways. I'm just doing it live instead of like recording it. It happens. Okay, so over here, I have a positive x, a positive y, and a positive radius, because radius is distance. Distance is always positive. If I do sine over here, I'll have a positive over a positive. I'm going to get a positive sine. If I do cosine over here, and this is my little angle, by the way, I'll have a positive x over a positive r, which is positive. And then tangent, here's something that you don't know. Tangent of any angle is sine of that angle divided by cosine of that angle, which simplifies to y over x. So if I had a positive sine and a positive cosine, my tangent's also going to be positive. So all of the trig functions, even the other three, because they're all just the flipped over versions of these, all of them are positive over here. Okay. But if I go on the other side, I'm going to have, somebody's glitching out. On my screen it says how many viewers I have, and I have 2, but I had 3 for a while. I don't know where you went. Maybe this is not useful. Or maybe you're just glitching out, I don't know. Okay, over here. Remember how sine is y over r? Well, over here I have a negative x, but a positive y. We'll just make a different triangle. So my x is negative because it's going to the left, because it's a normal graph. So my sine will be positive, but my cosine will be negative. And because tangent is sine over cosine, that'll also be negative. So only sine is positive on this side. Now, when I say only sine, I mean sine and its buddy, cosecant, because they go together. They're BFFs. Not like that, but you know, whatever. No judgment. And so what we say is that as I go around the circle, I focus on the S over here being positive. I'm going to skip a couple steps on the next one, but it's going to have a negative x and a negative y. So my sine and my cosine will both be negative, but my tangent's positive, because a negative over a negative is a positive. So only tangent's positive over here. And then over here, I'll have a positive x but a negative y. So I'll have a negative sine, a positive cosine, and then a negative tangent. So my cosine is positive. So what we say is, to remember this, if we go around in the C shape, right? Because my quadrants go in a C shape, 1, 2, 3, 4. As we go around in our C shape, what we say is we say that all students take calculus. Now, I had a group of kids that were like, nope, we are not taking calculus. And it hurt me because I was the only math teacher, so they knew what they were getting into. Whatever. So when it says all students take calculus, that means that all of them are positive, sine is positive, tangent's positive, cosine's positive. The rest are negative on that case. They made up a statement about avocados or aardvarks or something, but none of us can remember. They're on my Facebook, so I asked, and none of them can remember what the thing they made up was. So I'm sticking with all students take calculus. Even if you don't, I'm going to yell this at you when I do this math. And this is what it means. So we say all students take calculus. All students take calculus. I'll rewrite it because it's so important. Okay, so that's the important information from this one. Let's use this in a information thing. Let's use it. So let's say that I have never done that with a dot dot. Let me put it on a shelf so it's not weird. It was like aardvarks and something about cucumbers. I don't remember. Okay, so let's do this. We're going to say that we have a point. What point did I pick? Negative 4, 3. Now, normally I just shorten the words that they say, but the words confuse enough kids that I'm actually going to write it all out and tell you what it means. So, negative 4, 3 is a point on the terminal side of an angle theta. Also, pause. Angle is A-N-G-L-E. If you start writing E-L, it's angel, and that's different. Okay, continue. In standard position. Done. Find the 6 trig functions. See, somebody else is back. Good morning. I love it. That's the same kids that normally come to these. Getting nobody new. It's fine. They'll come. Probably didn't give enough information. Okay. Let's do it. I have a normal graph. And on my normal graph, I have a point, -4, 3. That's my normal point. Okay. That's on the terminal side of an angle. So what that means is, remember I had this, I'm going to go way back now, 2 weeks. Remember I had this angle? This is the terminal side, just this green part. So on this, I have an angle, and that's the terminal side. It goes through that point. So here's my angle theta. So here's what I'm going to do. I'm going to make a triangle out of this. Because I know how to find certain things based on a triangle. Let me make it bigger. So in my triangle, I already know 2 numbers. I know that it's -4 this way and 3 up, because that's the point that it's at. And then if I do a little bit of Pythagorean Theorem, -4 squared plus 3 squared, it's going to make 5. And somebody later is going to be confused, so I'm going to do that math real quick. -4 squared plus 3 squared equals r squared. That's 16 plus 9 equals r squared, so that's 25 equals r squared. If you can't take a square root yet, go back to my Algebra 1 stuff, because you're gonna need it. And then a lot of people are going to ask me where the angle is. It's at the origin. Okay, so just because this angle was way the heck out here, I'm going to use the triangle where the angle is in here. So that's my little dude. Okay. Now, there's a million ways to do this problem, you guys. We can stand here and do SOHCAHTOA, Kashib, whatever I said a couple weeks ago. Or, now I know some more things. Oh, right here. About y and r and stuff. So I know that sine of this angle is going to be y over r. Well, my y value is 3, and my r value is 5. Okay. My cosine at this angle is going to be x over r, so that's -4 over 5. See how it's negative? That's good. And then tangent at this angle is either sine divided by cosine or y over x. So 3 over -4, but I don't like to put the negative on the bottom, so I just put it in front. I don't like negatives on bottoms. Am I done yet? No! It says to find all 6 trig functions. So I also have to find cosecant, secant, and cotangent. Now remember, these are the opposites of their counterparts, and every C has an S. They're buddies. Or everything needs a C, because tangent's not an S, but it's fine. Okay, so if sine is 3 over 5, cosecant is 5 over 3. If cosine's -4 over 5, secant's -5 over 4. And if tangent's -4 or 3 over 4, cotangent's going to be -4 over 3. So those are my 6 trig functions. I shouldn't have written so much. I need to do more things. Oh, I paused. Oh, I broke paused. It's back. Okay, here's my problem, you guys. I did break, and you missed all of my stuff, so I'm going to go back and... I think I'm back. It's fine. Hey, I'm also recording this, just in case this happens. So it's 3 over 5, cosecant's 5 over 3. If cosine's negative 4 over 5, secant's going to be negative 5 over 4. And if tangent's negative 3 over 4, cotangent's negative 4 over 3. So I flipped them. Okay. And then all those 6 things are my answers, so I put it in a box. So I need all of them. Okay, let's talk about this thing called a reference angle. Whoa, that is not how I spell angle. Guys, I don't have any white out. Okay. The reference angle is the shortest angle from the terminal side to the x-axis. I need white out here. Maybe I'll do an Amazon run. And by run, I mean order. Okay, so the shortest angle from the terminal side to the x-axis. This was the reference angle right here. Because my full angle went all the way to here, but then I just went to the x-axis. I went bloop, and that was my angle. These are super useful because... Ooh, my cat just wiggled the doorknob and it scared me. Because, let's say, so I have this angle right here was 30 degrees. Let's say I have another one that's also 30 degrees, which was here. This is the exact same triangle. Yes, Rocket's at the door and he scared the heck out of me. He was snoring next to me. It was fine. Okay, so this triangle right here at 30 degrees and this triangle right here at 30 degrees will have the exact same numbers as my sine, cosine, and tangent. The only thing that's different is if it's positive or negative. No, he's in. He wanted out, but he stretched and jiggled the doorknob. He's over there. He's out the window. He might make a graceful appearance. I don't know. Okay. So sine, cosine, and tangent will be the same at 30 degrees if it's over in quadrant 1, quadrant 2, quadrant 3, or quadrant 4, based on the reference angles. Okay, let's go back. That's why it's useful. So let's just, for example, let's find the reference angle. And I'm going to use a radian because it's going to be confusing. So let's do 5 pi over 6. 5 pi over 6. Okay. If you watched my video last week, or this Monday, I walked you through how this was made. And there was these little fraction circles, and I would show you again, but I didn't save it to this computer. So 5 pi over 6 is right here. Okay. This is its reference angle. This is how far away it is from the x-axis. Because this is the x-axis. This is my home base. This one is the same size as this one, which is 30 degrees. So, I should probably sketch this so I have it in my notes, though. Right, so 5 pi over 6 is right here. And then this is 30 degrees. We don't write degrees if it's already in radians, though. We write the radians version. That's a pi over 6. Once again, I really want pi over 6 to be 60 degrees, but they switched. right? Pi over 3 is 60 degrees and pi over 6 is 30 degrees. And I'm sorry, but I don't make the rules. I just teach you how to break them. Here's how we break the rules. Let's evaluate cosine at 5 pi over 6. Now, I'm going to be very stickler about this. We're going to evaluate this without a calculator. And I'm going to show you why. Because if I type in a calculator, it's going to give me 0.866. I don't want that. I want the fraction version that I made last time. So, we know that cosine of 5 pi over 6 is this angle right here. It's the same thing as pi over 6. So it's the same thing as cosine at pi over 6, but it's in quadrant 2, and all students take calculus. So sine is positive, so cosine's negative. Okay, I need to like annotate this because somebody's going to get confused. I don't want to throw in a random color though. This is from all students take calculus. And then the pi over 6 is the reference angle. So here's what we do. And by the way, this is a long lesson for this, and that's why I did an entire day on the unit circles. I didn't want to make the unit circle and then use it for this stuff. So what we do is we go back to our cheat sheet that we made last week, and I look at what cosine is at 30 degrees, or at pi over 6. It's root 3 over 2. So negative cosine at pi over 6 is going to be negative root 3 over 2. We did it. I'm going to do literally one more. I have 2 more in my notes, but I just want to show you what it looks like when I do a secant one. Because my 2 other examples are one that's a negative degrees and another one that's a secant. Maybe I'll do secant of a negative degrees. Let's just do all the things at once. Ugh. Guys, I wrote example 1 up here in a box, and then I wrote example 2 down here without a box, and then I didn't even write example next to this one. I'm a mess. Evaluate. Let's do secant at negative 120 degrees. Okay, let's just do that one. Oh my gosh, I'm so sorry, Maya. This is a lot of stuff at once, and I totally get it. Let's do this one slower. Okay. Okay. So, secant at negative 120. My first step is to figure out where the heck this angle is, and then I can figure out the rest from there. So, let me just make a little unit circle. Not a little unit circle. Let me make this angle. And I'm going to use my reference guide. See how 120 is up here? So it's like one little triangle past 90. But this one says negative 120. So I'm going to go down, but basically the same. So that's negative 120 degrees. Okay. I need to find the reference angle. That's the closest x-axis to this angle. That would be 180, right? So if I go 120, I have just a little bit more till the 180. That's like 60 more. So that's 60 degrees. That's my reference angle. And then all students take calculus. Even if you don't. So down here, I know that tangent's positive, but cosine and sine are both negative. And secant is the same as a cosine. So secant of negative 120 is going to be negative because it's in the third quadrant, because it's right here and only tangent's positive down here. It's going to be negative secant of 60 degrees. Now we don't know secant. I didn't tell you those last time, right? I didn't give you those. I gave you cosine and stuff. So let's make it one more step confusing, because why not? Secant is the opposite of cosine. So what I'm going to do is I'm going to say, okay, well, cosine at 60 is 1/2. So then I flip that over. So I know that secant at 60 will be 2/1. And there's my little thought bubble. So then it's -2. I'm gonna wait for the chat to check in. So I'm gonna switch to the homework really quick. It's right here. So this one's like my first example where we had 4, 3. So it's a little bit different numbers. This is where you just find the reference angle, figure out how far away it is from the x-axis. And then these ones are that last part where you figure out what it equals using our cheat sheet. My cat's meowing at the door. He's fine. So I'm waiting for the chat to catch up so I can answer any questions. And then that's the end if you're done. And it should be, because it's half an hour, and I want you to be able to have time to do these too. And I give you only an hour total per week now of work. Although part of that was me trying to figure out this stupid, recording happening. Okay, catch up. Where did the half come from? What a great question. See, I knew these would come here. This half right here, I'm going to assume. So this half, the lesson that dropped, I know, he's going to attack me in a little bit. This lesson that dropped, the half came from cosine in a 30, 60, 90 triangle, which was from geometry, which most people forget how to do. So if I have a 30, 60, 90, it's based on a equilateral triangle. So this side's 2. This side's half of that, and then I do Pythagorean Theorem to find the other one. So cosine at, did I say 30? No, at 60. So cosine here, remember SOHCAHTOA, cosine is adjacent over hypotenuse. That's where the 1/2 comes from. So that's where the 1/2 comes from. But I just looked at it in my little cheat sheet table, because making the cheat sheet table is an in-class kind of thing that I expect you to be able to do, but not during home learning. But is a thing that you should be able to use this chart. So that's where the half came from. Other questions? I'm ready. Let me go get my cat. You want outside time? Come here. I'm just going to open the window for him so he gets some fresh air. Hopefully no trucks honk. Alright. It hasn't even caught up with me yet. Okay, cool. I like the O, okay. I'm writing the send home packet for this lesson. Y'all, this is rough. Can you imagine learning this from a typed up piece of paper? Okay. Any other questions? I'm ready. If you're watching this on Monday, I don't know how to keep certain parts and delete certain parts. So you might be watching this, but all you needed was up to that point. But if you want to keep watching to see if there's any more questions from those who will watch live, please do that. And if you have questions for me, what am I looking for here? Email me, come to my office hours. I'm ready. Okay. Hey, you guys. First of all, I really appreciate you coming and watching live. That was a lot of fun, and I'm glad that I got that question at the end, because it is confusing, and if you can't ask me in real time, I don't know that it's a question. So I really do appreciate you being here. I can email you. I can't post the homework ahead of time because it'll confuse some kids, but I can email you the homework if you want it. Or it's just going to be up on this channel. It's going to post right now. I just can't link it in the Google Classroom yet. So you can get a head start on that if you'd like to. Otherwise, it's going to be posted on Monday officially. And my office hours today are at 3. Today's Wednesday. My office hours are tomorrow at 11 or Friday at 2. So I'm here for you. Thank you for doing this. You rock. You're the best. I don't have an end screen. I'll go back to the homework as the end screen. Okay, bye. Yes. Yes, Naya.